Hi guys, Shouvik here. Welcome back to our YouTube channel. So today we will solve another question from Leetcode itself. So let's get started. Yes. So today we have count largest group. So this question is tagged as an easy, but the way they have written the problem statement, that makes it like easy, not an easy for sure. But if you can get the gist of the problems, then and if you can think on the correct directions, then it is obviously a very easy problem. So what they have given to us, they have given an integer in. Right, they have given an integer in can be an integer which you can see in the range of 1 to 10 to the power 4. Now each number from 1 to n is grouped according to the sum of its digit, so now you have a group of numbers from 1 to n and you have to group them according to the sum of the digits, and finally you have to return the number of groups that have the largest size. It is as simple as that, if you can get the gist. So now on this example test case, you can see now we have 13, right? Now we have 13. So how in they have given us 13. So how many numbers we have? We have 13 numbers from 1 to 13, and now we have to group them. So we create a group with 1, right? Then so if I can write it in the dry run basis, then you can, on the same go, understanding on the problem statement, you can get the intuitions also on the same go. So let's go to our OneNote. So where is our OneNote? Windows OneNote. Okay, it's relaunched, I guess here. Yes, it's relaunched. Okay, so let's suppose you have some number. From it's not writing. Okay. Let's suppose we have a number from 1 to n, and now we have to group them. So let's suppose our n value is 13, what they have given to us. Now we have numbers from 1 to n here, so we can start creating a group. So 1 can be part of a single group, the very first initializations. 2, another one, 3, 4, 5, right? 6, 7, 8, 9, 10. Like this way, you can group the numbers. You can group the numbers into different groups. First create a dangling groups. So everyone is a part of itself as a group. Now what they have asked, if the digit sum of the numbers are identical. So here you can see the digit sum is 1, and on 10 you can see the digit sum is 1. So you can pair them. You can group them together. For 2, it can be grouped with whom? 11. It can be grouped with 11. For 3, do we have any? Yes, we can group with 13. We can group with 13. For 13, we have 4. Now, so others we can't. Others should be on dangling only. So now we can write it which are paired. 1, 10 paired. 2, 11 paired. 3, 12 paired. 4, 13 paired. So how many grouped? Now they have asked for, you have to pair the numbers, you have to pair the groups which digit sum is same. And now, like this way, the group which has the largest size, you have to return the count of the largest size group. So in all of them, what is the group size? Is 2, because we have all of them has size 2. So the largest size we can achieve is 2. And how many group we have? Which has largest size? We have 1, 2, 3 and 4 groups. We have 1, 2, 3 and 4. So we have to return 4. I think the problem statement is clear to you, and the intuitions also you guys should be get. So here you can see, so there are total 9 groups, and out of the 9 groups, 1, 10, 2, 11, 3, 12, 4, 13, this has the largest size. So they have written 4. So for n equals to 2, 1 and 2 of size 1, that is the largest size. So they return 2. So yes guys, the problem is as simple as that. Now I think on that OneNote dry runs, you guys already got the gist, but if you not, then I will just give a pseudocode level dry runs, then so that you can get the gist on the, like, the basically the pseudocode or the code is going to be set on your brains as it is, right? So what actually actually the key factors of grouping? What actually the key factors of grouping? It is the digit sum, it is the digit sum, it is the digit sum. So rather than creating dangling groups, if for a particular digit sum, if for a particular, we know that digit sum is the key, we know the digit sum is the key. So for that particular digit sum, so here you can see, so if we can carry some things like for 1 we have, so digit sum as in 1 we have couple of elements, digit sum as a 2 we have couple of elements, digit sum as a 3 we have couple of elements. So if we can think kind of hash tables or a dictionary where the key should be bound to, because it is very intuitively you guys are getting also, like we are grouping the elements based on the digit sum. So our key should be the digit sum, the key should be our digit sum, right? Our key should be digit sum, and for that key how many values, val1, val2, val3, val4, like this way how many values we have, we can store them in a list, we can store them in an adjacency list, kind of graph. So for a graph we have a key, and for that there are multiple vertices, a particular vertex are going to be connected. So here also for a particular digit sum we will check how many values, we will push that values to a list for that particular key. So for a particular key we will carry a list of elements which are satisfying that particular digit sum, right? And on the problem statement they told already that we have to consider 1 to n all the elements. So I think the problem is very simple then. So we can create a frequency map, not a frequency map, a key as a number and value as a list kind of hash tables in Pythons by using default dict of list, by carrying a default dict of list, right? We can create it by a default dict of list. Now we can iterate. Now we should have to iterate for each in range what? Tell me guys. 1 to n plus 1. N plus 1 means like n plus 1 is exclusive, 1 to n. And we can create an element variable and stored it our each value, because we have to find the digit sum. So we can initialize our digit sum as 0, right? And while our each is still live, so now we have to find the digit sum of that particular elements. So it is very simple, right guys? What we can do, we can increase the digit sum, plus equals to each modulo, tell me guys, each modulo 10, and our each every time is going to divide by 10. So that's the reason I stored it on a element value, because we are at the end of this for loops, we are distorted our each, so we have stored that elements, each elements to an element variables, right? So that's the reason I have created a variables here. Now it is very simple. Now for our default dict, our key should be, we know, digit sum. So for that digit sum we got another elements, we not sure there can be previous elements, but for that digit sum we got another elements, we are storing our elements, right? Now we have to check, now what, now like this way we have all the elements which are same digit sum are clubbed, to a list. Now what we have to check, now very simple, so before that maybe if we can carry a max size, like till now what is the max size we have identified, we can carry as a 0, and we can create and count how many count that we have to return, count is also 0. Now if at any particular times, if lane of that particular digit sum, dd of digit sum, so for that particular group, if that particular group length is more than my max size, so what it means guys, so it means that we got a group which is more than my previous considered max size. So we have to reinitialize our max size with the lane of dd of digit sum, exactly same things, exactly these things, and else tell me guys, and our count, how many count we still now encounter for this, count is also going to reset, it is of 1, and else, very simple guys, very simple. And if my lane of dd of digit sum is equals to my max size, then that means we got another candidate of same max size we are carrying. So on that case we have to increase our count, because we got another elements, we got another group which is also satisfying another elements of digit sum, which are also satisfying my count, which are also satisfying my max size. So on that case we have to increase our count also. So finally we can return the count. Yes guys, the problem is as simple as that. Now I can quickly iterate you to the code. Yes, so I have initialized my dd as default dict of list, and here I am doing the stuffs that max size I have initialized as 0, and I am doing the things for each in range 1 to n plus 1. Digit sum is 0, element is I have initialized with each, and then I am doing the exact same things to do the sum of all the digits, straightforward, and I am appending that particular elements to my elements. And if at any particular point of time it is greater than max size, I am re-initialize my count with 1 and max size with len of dd of digit sum. And if it is hit the max size, then I am increasing its count. Yes guys, the problem is as simple as that. And now if we can quickly discuss the time complexity for this particular problem. So tell me guys, the time complexity. Yes, we are performing everything on a single iteration. So whatever the n value, we are just iterating on that. And on space perspective, we are carrying a digit sum to all the values, right? So it is also a kind of like big O of n space it is going to occupy for sure. More than I think big O of n, but yeah, in terms of big O of n only, it is not a big O of n square. It terms of kinds of a big O of n only, because digit sum is also on the range of. So if your n is as big as 10 raised to the power 4, so what is the largest number having the highest digit sum? It is like triple n, right? Sorry, 10 raised to the power 1 to the power, after 1 we have 4 zeros. So if I can write it, 10 raised to the power 4 digits, I think one more, yes. So this one can give the largest digit sum. So digit sum can grow kind of like 36. So you can write it exactly as a 36 into n. So we can have at max of 30 size keys to our dictionary, and every dictionary is just storing the n value. It can be grow to like first digit sum, second digit sum, or 30th number digit sum, 29th digit sum, anything. So the list, sum of the list we are carrying, it can grow as big as big of n, and key can grow as big as 36. So that we just prove. Yes, so that is the most optimal solutions, time and space complexity, and my solutions is like 95% faster than all the Leetcode submitters. So I am definitely sure that is the most optimal time and space complexity we can achieve for this particular problem. And if you guys are able to understand till this point, I guess you guys are already doing. Please do subscribe to our channel, and please share the videos who are also preparing for top product based companies, and who are also brushing up their DSSP, so that they can also get most of it. And please turn on the notification so that when we are going to live with our next video, you can get the notification as soon as possible, guys. So yes guys, that's it for today. Let's meet tomorrow with another beautiful question. Bye guys, bye.